Hello, welcome back. So this video is going to be over RC circuits. So let's just get right into it. So I started off with kind of a basic overview of resistors and capacitors in series and parallel, what their respective equations are. So I'm going to be referring back to this a while as we go through the problem that I decided to solve for you guys today. But yeah, just to briefly go over it, resistors in series add together. So if you have of them all three in a row, then they just add together. However, if they're in parallel, it's the inverse. This should be 1 over, sorry. The inverses add. But the opposite is true for capacitors. Capacitors in series add their inverses, whereas in parallel, they just add together when they're in parallel. And then the equations, resistance is just voltage over current, capacitance, it's charge over voltage. So knowing that, let's get right into our problem for today. So I picked a pretty hefty circuit. Looks scary, but it's not that scary. So let's just kind of get right into it. So this problem is going to kind of deal a lot with what language is being used in the problem and what it's asking. So let's just keep that in mind as we're solving this problem. So it says in the circuit, capacitors are initially uncharged, the battery has no internal resistance, and the ammeter is idealized. And it says find the ammeter reading just after the switch is closed and after the switch has been closed for a long time. And I also want us to find the effective resistance and effective capacitance of this circuit. So the first thing we should do is let's start with finding the effective resistance and effective capacitance of this circuit. So let's start with resistance. Okay, so let's find the effective resistance. Okay, so let's do this. Okay, so let's find the entire effective resistance for the entire circuit. So the first thing that we're going to do is we're going to come over and we're going to go up this one. And so the first resistor that we encounter is this one. So we have the first one we have is a 25 ohm resistor. And as we keep going, we see that it is in series with a 75 ohm resistor. Okay. As we move along, we come to two junctions. So we have this one right here and this one right here. So at our first junction, as we go down this way, we have a series of two 25 ohm resistors. So as an aside, I'm just going to say that at junction 1, let's call this junction 1, we have two resistors in parallel, so they're in series, each at 25 ohms, which is 50 ohms. And then we have a 50 ohm resistor in parallel with that. So at J2, we have a 50 ohm resistor. So now I want to find the effective resistance for just this parallel part. So we have, let's call it R2. So R2, 1 over R2, because if we remember from this one, we have that property right there. So 1 over the effective resistance will be that. So we have 1 over 50 ohms plus 1 over 50 ohms. Again, I just added the two together that were in series in the first junction. So 1 over R2 equals 2/50 ohms. And now we want to solve for R2. So 2R2 equals 50 ohms. I just did some cross multiplication right there. So R2 equals 25 ohms. And that's the effective resistance of that part. So then from our effective resistance, I'm going to add another 25 ohms because that's what we found that this section to be. And then we add one more 15 ohm resistor to the mix. And that is our total resistance. So let's add that all up. So we have 100 ohms plus 25 ohms plus 15 ohms. So 125 plus 15 equals 140 ohms. And that's our effective resistance. Okay, now let's do capacitance. Okay, so the first one, we go this way. And remember, so in series, capacitors go of 1 over. So I'm going to start off with 1 over the effective and go from there. So 1 over the effective capacitance. We start with our 15 ohm, or 15 microfarad. So 1 over 15 microfarad. Then as we go to the right, we have 2 new junctions, and these are in parallel. So I'm going to make a new junction. We're going to call it parallel. So since these guys are in parallel, they add together just how they in just regular. So that's 20 microfarad plus 10 microfarad. So this entire section gives us an effective resistance of 30 microfarad. But since it's in series with the 15, we have to add it as 1 over 30 microfarad. So what I'm going to do is I'm going to multiply this by 2 to get the same denominator. So we get 2 over 30 plus 1 over 30 plus 3 over 30. And then we want to find the effective capacitance. So I'm going to say 1 over CE equals 3 over 30, or 3 CE equals 30, divide by 3 on both sides, and we get our effective capacitance to be 10 microfarads. Okay, now let's do what it was actually asking us to do. Okay, so we have completed this part right here that I added on. Now let's do part A and part B. So part A, and most of these questions that are being asked about RC circuits depend on the wording. So in part A, it says just after the switch is closed, we want to find the ammeter reading, which is right here. The ammeter determines the current in a circuit between 2 points. So we want to find how much the voltage drops from right here to here. And so when it says just after the switch is closed, what that means is our capacitors in our circuit effectively act as a wire instead. So charge is just flowing right through them. So, so yeah, it's just effectively a wire. So what that means is when our current wants to choose the path of least resistance, it will opt to go through those wires instead of going through to the resistors in the circuit. So let's find what happens when the switch is just turned on. So when the switch is turned on, we start up here and we go up to our first little section of our circuit that we have, and the charge looks at it and says, okay, there's a 25 ohm resistor, or there's a free wire to go through. So I'm not going to go down to that 25 ohm resistor. I'm going to go through the open wire. But the charge encounters a 75 ohm resistor in the process. So that is on our list of things that we have to take into account. And then it comes over here, and there's a bunch of different ways to go, but it has a free wire right here. So it goes through here. And then there is another option for a wire, for a free wire here. So it definitely goes through that. But charge won't go through that 25 ohm resistor because it has two options to go through a free wire instead. But then the charge that decided to go through this 10 microfarad capacitor, or just this wire, when it's just turned on, it will go towards and go through this 25 ohm resistor and this 50 ohm resistor right here. And finally, as it ends, it has to go through that 15 ohm resistor. So now that we have all of the resistors that it goes through, let's find our effective resistance for this new circuit. So our R effective equals, so we're going to start with 75. And then we have a 50 and 25 ohm resistor in parallel. So I'm going to say that R1 over R2 is equal to 1 over 50 plus 1 over 25 ohms. So I'm going to multiply this by 2 to get our denominators the same. So 1 over R2 is equal to 1/50th plus 2/50ths, which gives us 3 over 50 equals 1 over R2. So going to cross multiply. 3R2 is equal to 50, so divide by 3, and R2 is equal to, we're going to leave it like that, 50 over 3. So we're going to add that to our effective resistance that we get, since those are in series with that 75 ohm. So 50 over 3 plus 15 ohms. So now we want to find our resistance. So 75 plus 15 equals 90. So 90 ohms plus 50 over 3 ohms. I'm going to multiply this 90 over 1 effectively ohm resistor by 3. So then we have that our effective resistance is 270 over 3 ohms plus 50 over 3 ohms. And that gives us 320 over 3 ohms. And now we want to find the current. So we know that V is equal to IR, but we want to find the current. So we're going to divide by R. So our I is equal to V over R, effective resistance of the entire circuit. Our battery says that it's 100 volts, so we have 100 volts over 320 over 3 ohms. So we can multiply by the reciprocal and get, so 3 over 320. So we are getting 300 over 320, which equals 0.9375 amps. And that is our current when it has just closed. What about after it's been closed a very long time? After the switch has been closed a very long time, what effectively happens is we have an open circuit. So we have a kind of a broken, they call it like a broken circuit. So there is no more, this just kind of becomes an open hole. I'll draw like a circle. It's a hole. There's nothing there after a long time. So that happens to all of the capacitors. So now let's count what resistors we have to go through now. So we definitely have to go through this 25 ohm resistor. We definitely have to go through that 75. Now we definitely have to go through this 25 right here. We don't reach that 50 ohm one. We definitely go through that 25 and we go through that 15. So now we want to find our effective resistance now. So now we don't get to go through this line. So we don't have any more parallel resistors. We just have everything's in series. So we have 25 plus 75 plus 25 plus 25 plus 15. So that gives us 100 plus 50 plus 15. So that gives us 165 ohms. And now our reader should say 100 volts over 165 ohms should give us 1.606 amps. And that is how you solve a problem with RC circuits. I hope that this was helpful. I will not be giving a video next week because I am going to go see Taylor Swift live in concert this weekend. So I will not be doing a video. But if you're seeing this before the exam, I am having some office drop-in hours on Tuesday night from 6:30 to 9. And I hope that you guys can come with questions. But I will see you next time. Happy studying.